So it seems we're live now.
Yes, we are probably live. So hello everyone. So good morning. So we're just waiting. The
Okay.
session channel should be moved here in terms of
Okay.
So
Yes, I am also live. I see Lawrence and
Yes,
Lawrence
hello.
in the backstage. Hello, Lawrence. So you are going. Who is going to present? Lawrence.
Yes, I am going to present.
Okay, so I leave to you the floor for presenting a framework for the automation of testing computer vision systems.
Thank you very much. So yeah, as already said, I'm going to present to you the short paper, a framework for the automation of testing computer vision systems. And together with my colleagues, Franz Swotova and Lidio Chihai, I wrote this paper, and I have the honor today to present it to you. So I would like to directly jump into the agenda of my presentation. So at first, I will give a short introduction, what were the objectives behind. Then we'll come to some preliminaries. I will explain to you and show you the testing framework itself. And then I will show to you the experimental study and also the preliminary results we got out of the study. And in the end, I will give a short conclusion and the outlook of future work and what still needs to be done and will be done. So what were the objectives? As you all know, vision systems are more and more used in practical applications. Should it be autonomous cars, mobile robots, and also inspection tasks, for example, for quality assurance things. And often in such systems, neural networks are used. This can be convolutional neural networks, can be other types of neural networks. And often these neural networks extract qualitative or quantitative observations from these images to make some conclusions. And therefore, also in the recent years, a lot of work has put into quality assurance and testing. And of course, this quality assurance and testing of the correctness and the robustness of such vision systems is of crucial importance. Should it be meeting regulations, or is it simply to ensure the quality of a surface, for instance? So what it's worth noting is that testing vision systems does not necessarily only include testing the vision algorithm itself, so the neural network itself. But it should also include the hardware, which is included in the complete system, because in the end, all of these things have to work together smoothly. And so we thought an easy to use and uniform and also expandable framework for automating the generation of tests for such vision systems would be desirable. And the intended use of our framework is basically for a quality inspection system for riblet surfaces, which is currently in development. So therefore, we used for now for our experimental study different systems. At the bottom, you can see a small schematic. So you have an input image, an image classifier, and the output would be pass or fail. And on the right side, you see some examples of the test generation, but I will go into this in the next slides. So the preliminaries. We make use of image modifications to create adversarial examples, which in the end then be our test suite. And with these examples, the final system, the final vision system, should react differently depending on the modification. So we have there split the thing in two major groups, the minor modifications and more severe modifications. For minor modifications, the system should be robust. So if there are just small modifications and small changes, the system should still deliver the same quality measure. But if there are more severe modifications, the system should, of course, throw an error message. And in the best case, also indicating the problem. So for instance, if the input image is a completely black image, the system could throw an error message indicating the problem that there may be a broken light, which causes the problem. At the bottom, you see our test suite generation. So as I said before, we have two major groups, and this is also displayed here. So we have a test suite for minor modification and a test suite for severe modifications. All of these groups basically have the same initial test suite. And then we have an input image. On this input image, modifications are applied, and the so-called similarity checker. And this similarity checker gives us feedback if it is a severe modification or a minor modification. If you're interested in this in more detail, it's more in detail explained in the paper, and we can also have a discussion offline, of course. So here, a brief overview about the testing framework itself. Basically, the testing framework consists of an input image, a modifier part, a similarity checker part, and the test treats which are generated, a classifier, and evaluation part. So since our initial system is in development, we make use of a so-called mask RCNN. This is a convolutional neural network which classifies objects in images. And we applied different modifications on our example images. This can range from pixel changes, fine transformations, weather scenarios, darkening, brightening, all of this. So we make there a random choice here, also to show that this framework can basically be applicable to other domains too. And the similarity checker uses the so-called structural similarity index measure. This is our measure we used for our first experimental result to check if there is a severe modification or a minor modification. And then in the end, there's the evaluation, which gets the output of the classifier and compares it to the expected output. So our experimental study consisted of some example images we have chosen, and the mask RCNN, which I explained before already. And we also chose different images from different domains to show its wide range of applicability. And as you can see on the right side at the bottom, we have there images from cities, from driving scenarios where a policeman is driving a motorcycle, or even stop signs. And of course, depending on then the application domain, you can add different modifications which suit your domain. But what we have found out in our first experimental study is that there is only little correlation between the structural similarity index measure and the degradation of object recognition. So for instance, for one image, we found out that there is absolutely no correlation regarding the structural similarity measure, but the object detection was basically correct. So we need to further investigate there what causes this phenomena. And this brings me already to my conclusion and outlook. So as I said, we introduced the framework for the automating the generation of test suites for vision systems especially. And this framework consists of 3 parts: a classifier, a modifier, and a similarity checker. And the first results have shown that there is not that much correlation between modifications, object detection, and the structural similarity index measure. So what are we working currently is, and what we will do in the future to improve this, is we will make further investigations why there is at some points little correlation and some points there is correlation. We plan, and we already do, test different neural networks. We plan to make some kind of mapping if there are some specific modifications which causes this phenomena, and also include different modifications. And also the evaluation process itself is currently in development, so that everything is automatically done, and also that everything is smooth and easy to use and uniform to handle all this framework, and also be applicable to different domains. And basically, this is the end already of my presentation, and I'm happy to answer questions if some arise, or if something else is of interest for you.
Thank you, Lawrence. I clap for the audience.
Yeah.
Yes, I did not mention when I introduced my fault that this is a short paper, so this is why your presentation was quick. We have
Yes,
5 minutes for some question, and as usual, question can continue also in the discussion room in case. And to warm up the audience, I will make you a very, very basic question. Sorry, it can be naive, but
no problem.
I am not an expert of vision system. So while you presented, I was a bit confused by the fact that we use image recognition now in very advanced way. We can search images in Google and so on.
Exactly.
So what is the baseline, and what is that if you can explain to a not expert, what is that you are going to improve with respect to existing approach?
So basically the approach right now is that you have for some vision system a training set and a test set, and basically you test your vision system on the test set. And it was found out that also small pixel changes. This can be just one pixel change, can lead to a completely different output of the vision system, although it performs good for the test set. And therefore, if we apply or create some kind of adversarial example, we go in the direction to make the system more robust against such changes which may not occur in the test set.
I see. Okay, very clear. So you are focusing now on the precision of recognizing. So this is why your example was on this surface.
Exactly. So basically, the framework should be used for this surface inspection vision system. But since it's still in development, we thought, okay, let's try it out, and we found that the framework itself basically works. Of course, then when the system is there, there needs to be done some fine tuning. As it is everywhere, fine-tuning has to be done in the specific domain. It has to be defined which modifications suit the domain and so on. But basically, the framework, it was the intent that the framework should be easy to use, also easy to integrate anywhere. And so we work basically on this more, so that it's easy to create some test suites which might not be available with the training and test set itself.
I see. Okay, I don't see other question from the audience in the chat. Okay. I wait.
We have some more minutes.
We have 3 minutes actually.
Yes.
But I would like to leave 1 minute in advance, otherwise I am late with the other live.
No problem. Maybe I can mention if some questions arise later, the email addresses are on the front, so you can always contact us, and we're always happy to have a fruitful discussion about these things. So
yes,
don't be shy and always contact us.
Very good. And also you can go to the discussion room, where I suspect that the audience should be able to make you question also by voice, but I have never experimented so far.
I will have a look there.
Okay, thank you, Lawrence, Franz, and Leidio. So I stop video here, and thank you again.
Thank you very much for the opportunity to present here.
Thank you, and I wait you to AST next year as well.
Yes,
okay.
Hopefully.
Okay, so I see you in a moment in the next paper.
Yes.